I should have included this little summary in the previous video on central limit theorem talking about sampling distribution, but I'll I guess make it a separate video quickly on as a summary of the central limit theorem. Well, you have a population distribution that has differing degrees of unusualness, and you measure those degrees of unusualness with a z-score, and that z-score is just the deviation of a measurement divided by the standard deviation, the average of those deviations. How many of those standard deviations does it take to equal that deviation? And in the sampling distribution, the distribution of sample means, the same thing occurs. You have a sample mean also has a degree of unusualness. It's represented with as a test statistic, either z or t, if the sample size is relatively small. So you calculate that test statistic the same way that you calculate a z-score. It's simply a number of standard errors this time. It's how many standard errors are there in the error. And that's why we call it a standard error. Conceptually, it's the same thing as a standard deviation. These are totally analogous distributions, and a test statistic is analogous to a z-score. It's simply telling you, asking how unusual is this occurrence of a particular sample mean of a particular size. And remember that the standard error, remember one key is remembering that the standard error of the sampling distribution is the standard deviation of the population the sample comes from divided by the square root of the sample size. So that's a quick summary, and seeing them together I think helps to see how connected they really are. So actually, before I finish up, so there are really three things that the central limit theorem tells us. First, it tells us that the sampling distribution, if the samples are sufficiently large, the sampling distribution will be normal curve, a normal shape, even if the population the samples come from is not. If the population the samples come from is normally distributed, then the sampling distribution is guaranteed to be normally distributed, same shape, even if the samples are small. Okay. The second thing that the central limit theorem tells us is that the mean of the sampling distribution, it will be the same as the mean of the population the samples are taken from. And the third thing it tells us is that the standard error of the sampling distribution will be the standard deviation of the population the samples came from divided by the square root of the sample size. Remember, larger samples mean less error. Larger samples mean less error, and less error means a smaller standard error. If all these errors are smaller, then the average of those errors is going to be smaller. I hope that totally makes sense.